We are going to talk about the trig functions to find the length of the sides in a right triangle. Now, if you remember from grade 10 applied or 10 academic, we talked about SOH-CAH-TOA, which was a fast and shortcut to memorizing all these trig ratios. Now, just to remind you very briefly, S stands for sine, C stands for cosine, and T stands for tan. So S is sine, cos, and tan. A stands for opposite. A stands for adjacent. And H stands for hypotenuse. Now, using any one of these acronyms, you can just write the ratio for any one of these trig functions. Now, before I give you the formula, just remember two important terms that you learned previously was the angle of elevation and angle of depression. Now, if we assume that this line represents the horizon, angle of elevation is the angle that your point of view, okay, your eye makes with the horizon. So if this is the object and this is your eye here, the angle that it makes and it goes over the horizon is called the angle of elevation. Now, at the same time, if the object is below the horizon, the angle that your eye makes, your eyesight makes with the object, this angle which is below the horizon is called the angle of depression. So remember, these two are very important, one angle of elevation and the other one angle of depression. Now, just before we start with some examples, let's review the sine, cos, and tan ratio. Again, using the SOH-CAH-TOA, SOH stands for sine is equal to opposite over hypotenuse, which is shown here. Now, for any angle, let's say angle X, the opposite is the side which is in front of it for that angle. This side is already reserved, which is in front of the 90 degrees angle, which is called the hypotenuse. So the only side which is left is this side, which is called adjacent. And this is for angle X. For angle X, the cos is adjacent, which is this guy, divided by hypotenuse, which is this one. And the tan X is opposite over adjacent. Opposite is this, and adjacent is this one. Now, one thing you have to remember, if I change the angle, meaning if this one is angle Y now, the opposite to this angle is this side. So all the ratios that you had before is going to change. I'm going to write sine Y is opposite, which is going to be this side, okay, divided by hypotenuse, which is this side. If I call this side, let's say A, is going to be A over H, which is, let's say, this side. So just remember that if the angle is changed, the opposite and adjacent sides are going to also change at the same time. The first example, I have a point which is 25.4 meters from the base of a cliff. A land surveyor measures the angle of elevation to the top of the cliff as 72.5. What is the height of the cliff? Okay, when you have a word problem in trig, the first thing you always do is to try to plot what exactly the question is talking about. So I have a cliff which is 25.4 meters. So this is my cliff. Then I'm standing somewhere around here, and the distance from here to here is, no, the distance is 25.4. The height of the cliff is unknown. And then I know the angle of elevation to the top of the cliff is 72.5 degrees. The question is that what is the height of the cliff, meaning the value of x. Now, when you are trying to solve for x, look at the given information. I have the angle. I have the adjacent side. Remember, this angle, this side is adjacent to it. And I'm looking for opposite. So I have angle and then opposite adjacent. Angle opposite adjacent automatically reminds me of TOA, which is tan. So I can say tan 72.5 is equal to x over 25.4. Now, we know that the denominator here is 1, so I can just crisscross or cross multiply. So I'm going to get x times 1 is going to give me x is 25.4 tan 72.5. Now, if you use your calculator, this is going to give you about 80.6 meters. So this means that the height of the cliff is about 80.6 meters. Okay, the next question, we have a plane which is flying at an altitude of 5,000 meters. The angle of depression from the plane to the airport is 3.4. You have to find the direct distance from the plane to the airport. So again, let's assume that the plane is here and the airport is here. Okay? So this is P, which is plane. This is A, which is airport. Now, my line of view is like this one. Remember, by definition, the angle of depression is the angle that the line of view makes with the horizon. So this angle is 3.4. And this is my altitude, which is 5,000 meters. And I have to find this distance, which is direct distance from the plane to the airport. Now, there are two ways you can attack the problem. Either you can find this angle by subtracting 3.4 from 90, or another way of doing it is the following. If this is horizon, this horizon is parallel to the ground. So if this angle is 3.4, how much is this angle? 3.4, because of TPTZ, if you remember. Or you can say this angle is 96.6 degrees. Either, oh, I'm sorry, 86.6. Either way is correct. But let's go with 86.6. If I say this guy is 86.6 and I'm looking for x, which is here, which is the hypotenuse, and also I have this side, which is adjacent to this angle, I can use the cosine law. So I can, cosine ratio. So I can say cos of 86.6 is equal to adjacent, which is 5,000, divided by x. Now I am going to crisscross. Remember, this one is divided by 1. So I'm going to get x cos 86.6 is equal to 5,000 times 1, which is 5,000. So I get x. I'm going to divide by cos 86.6, both sides. I'm going to get x is 5,000 divided by cos 86.6, which is going to be about 84 kilometers. Okay, the next problem, we have triangle ABC. Angle B is 90, angle A is 35, side C is 10. We are supposed to find the lengths of all unknown sides, but we are going to try to solve the triangle. So the first thing is to draw the triangle. So I'm going to draw a right triangle like the following. But since angle B is 90, I know that this angle, which is 90, has to be called B. Now, I call this one angle A. I call this one angle C. Now, by convention, the side in front of angle A is called A lowercase, and in front of C is called lower c, and in front of B is called lower b. Now, based on the problem, angle A is 35 degrees, so this guy is 35, and side C, which is this guy, is 10 centimeter. Now, it is very simple to find angle C, because we know the sum of the angles inside the triangle is 180, so I can say 35 plus 90 plus angle C is equal to 180. Then I'm going to move 90 and 35 to the right and change the sign. So C is 180 minus 35 minus 90, which is 180 minus 125, which is 65 degrees. So we know that angle C is 65. Now it's a matter of using SOH-CAH-TOA to find the other two sides.
It's 55.
Oh, it's 55, sorry. Now to find side, let's say side A, I'm going to use the sine, the tan of angle A, because I know angle A is given. The opposite to angle A is side A, and also I know the adjacent is tan, so I can use the tan. So I can say tan 35 is equal to A over 10. Cross multiply, I'm going to get A is 10 tan 35, which is how much? 50?
What?
Oh, he's using the next.
That's 7.
Which is about 7 centimeters.
Yeah, it's about.
Yeah.
7.0.
Now the next one that we are going to find is side B. Now side B can be found a couple of different ways. One of them is using SOH-CAH-TOA again, or we can use the Pythagorean theorem, because we do have A and we have C. So I'm going to use Pythagorean theorem as a practice. I'm going to say that B squared is equal to A squared plus C squared, or I can say B squared is A squared. I know A is 7, so I'm going to say 7 squared plus C squared, which is 10 squared. 7 squared is 49, 10 squared is 100, so this is 149. Now if I take the square root of both sides, I get B is approximately 12.2 centimeter. So I found the angle C, I found the side A, and I found the side B. This means that I could solve the triangle.